first thing I noticed, I can't really do a U sub, so there's this old trick. What you're going to want to do is synthetic. So I'm going to divide this into the numerator. And remember, with synthetic, you put the opposite of what the bottom is, the denominator is, and you just write down the coefficients. And you do the synthetic process. So 1 and 0 is 1, and I multiply negative 1 times 1 is negative 1. And then 6 minus 1, that's going to give me 5. And be careful, this is the remainder column. So negative 1 times 5 is negative 5. 8 minus 5 gives me 3. So this is going to give me a new integral of x plus 5 plus 3 over the original denominator, x plus 1. And I can find the integral of that pretty quickly. The integral of x is x squared over 2. The integral of 5 is just 5x. And the integral of this is 3 ln x plus 1. And don't forget, plus c. Number 2, again, I cannot do a U sub. I can't do a U sub. So I'm going to implement synthetic again. Backwards box, I put the opposite, positive 1 in, coefficient 1, coefficient 5. And then this is a pretty quick synthetic. So 1 and 0 is 1, 1 times 1 is 1. And my remainder is going to give me 6. So my new expression is going to be the integral of 1 plus 6 over x minus 1 dx. The antiderivative of that is not too difficult. It's going to be the antiderivative of 1 is x. The antiderivative of 6 over x minus 1 is going to be plus 6 ln x minus 1. And don't forget the plus c. Number 3 is a definite candidate for a U sub. And I'm going to let U equal this complicated expression inside the parentheses. And notice when I take the derivative of x squared minus 1, that's going to give me du equals 2x dx. And what I like about this is that the x dx will line up with this dx and this x. And then I'll move me over into what I call the U world. So it's going to be a new integral of u to the 4th du. And notice I have this 2 dangling over it. I have to divide both sides by 2 to bring this 2 with me back over to the U world. And usually we just put that divide by 2 out front. Now the antiderivative of u to the 4th is not that tough. That's just going to be 1/2 times u to the 5th. But don't forget you divide by 5. So that's going to be 1/5. And then I'm going to spruce this up a little bit. That would give me 1 over 10 u to the 5th. But remember what my u was. My u originally was x squared minus 1. I throw that back in for u. And don't forget your plus c. Number 4, notice I have it highlighted what I'm going to let u equal. It's pretty apparent when I take the derivative of that, it's going to give me an x, which will cancel out with that x. So I'm going to let u equal 4 minus 9x squared. The derivative of u is going to equal negative 18x dx. And notice the x dx, simplify, x dx, it leaves me with that negative 18. And remember, we bring that out front. Don't forget the negative, new integral of the square root u du. The antiderivative of square root u, I hope you committed to memory, that's going to be 2/3 u to the 3/2. Don't forget the negative 1 over 18. So I have a little arithmetic to do over here. I have to back sub in the u with the 4 minus 9x squared. That's going to give me 1 over 9, 1 over 9, 9 times 3. So my final answer should be negative 1 over 27. 4 minus 9x squared to the 3/2 plus c. For number 5, notice I'm going to let u equal the red. It's pretty complicated. So I take the derivative. That's going to give me du equals just 2 dx. Notice the only thing that really escapes is the dx. But this gives me a little bit less complicated of an integral in the u world du. And don't forget, I have to divide both sides by 2s to bring this 2 over into the u world. So it's going to give me a 1/2. I'm going to manipulate this radical to be u to the negative 1/2. If I rewrote that as u to the 1/2, it would be down the bottom. But then when I bring it up, it makes it a negative exponent. Antiderivative, don't forget, we add 1 to the exponent. So my antiderivative is going to be the original 1/2. U to the 1/2. But then I divide it by 1/2, which is the same as multiplying it by 2 over 1. And this is going to give me just u to the 1/2. Or the square root plus c of my original u sub, which is 2x plus 1. Alright, this one's a little rough. What I'm going to do is let u equal x plus 1. Du is going to equal 1 dx. And nothing really goes away. And notice, the x doesn't simplify. So I'm still left with an x and a square root u in the du world. And I'm not allowed to have this x in the u world. So what I'm going to do is solve my original u sub and get x by itself. Notice if I have u equals x plus 1, if I subtract 1 from both sides, this is going to give me x equals u minus 1. So I can substitute this x with u minus 1. Now I'm totally in the u world. U minus 1. Instead of writing this as square root u, I'm going to write it as u to the 1/2. It's going to be helpful. And now what I'd like to do is distribute that. And u to the 1/2 times u to the 1st. I add exponents when I multiply. So this is going to give me u to the 3/2 minus, well, u to the 1/2 times 1 is u to the 1/2 du. And now I'm going to take the antiderivative. Adding 1 to this, that's going to give me u to the 5/2. And then I divide it by 5/2, which is the same as multiplying by 2/5. And then I think we've all done this one, but I'll do it the long way. That's going to give me u to the 3/2 times 2/3. I'm going to back substitute my original x plus 1 in for u, and this will give me 2/3 x plus 1 to the 5/2 minus, oops, that's 2/5, 2/5, minus 2/3 x plus 1 to the 3/2. Don't forget plus c. Alright, number 7. I did it differently in class, but somebody showed me a shorter way. Justin, actually. He said let u equal sine x. And then notice du will equal cosine x dx. The cosine x dx cancels out. And this gives me a new integral of just u to the 3rd du. Pretty sweet. And now the antiderivative is u to the 4th over 4. Back solve my sine. So it's going to be sine x to the 4th over 4 plus c. But remember, they wouldn't write it like that. They would put the 4th power in the back of the n. So it would be properly rewritten as sine to the 4th x. And they might put the 1/4 out front plus c. Pretty shrewd. I like it. I want to find the volume of the solid generated by revolving the region bounded by the graph y equals square root x, y equals 0, x equals 3, spun about the x-axis. Since I'm spinning about the x-axis, that means it's going to be with respect to x. So I'm going to graph the functions first. Square root x, that's simple enough. Y equals 0, that's the horizontal line. And x equals 3. So that's going to give me this shaded region. And I'm going to spin this about the x-axis. So the reflected image would look something like this. I'm going to start spinning it. As soon as I notice this, I notice it's going to be a disk and not a washer. So that's going to be from a to b of pi r squared times the height, which is dx, with respect to the x-axis. And now all I have to do is fill in the particulars. And notice this here was at x equals 3. This is at 0. So my integral is going to be pi from 0 to 3 of whatever my radius is. And my radius is going to be this expression, square root x squared dx. And I know that this is going to simplify, so that will just give me x. And the antiderivative of x is x squared over 2 from 0 to 3. So this is going to give me 3 squared over 2 minus 0. And I'm not forgetting that my pi goes in front of that. And that's just going to give me 9 pi over 2 for my exact answer. So I have the equation y equals 2x squared, y equals 0, and x equals 2. So y equals 2x squared is going to be a parabola. And y equals 0. And x equals 2. So there's my enclosed area. Goes up to x equals 2. But here's the tricky part. You spin it about this vertical line, x equals 2. So that means it's going to be with respect to the y-axis. That means I have to solve this equation for x. So let me do a little bit of that work first. And the mirror image is going to look something like this. And that volume is going to be a disk, which is nice to know. And let's solve it first for x. So I have y equals 2x squared. Divide both sides by 2. So y over 2 equals x squared, and then I square root both sides. So this curve is actually going to be the square root of y over 2, if you can read that. And my integral is going to be from c to d. So from 0 to whatever this value is where they intersect of the radius squared dy. So let's see if this is 2. When I plug 2 into x, that's 4. Because 2 squared is 4. 4 times 2 is 8. So my limits of integration for this are going to be from 0 to 8 of the radius, which is... This is an edit. I messed up on the actual radius. The radius in this case is from the center of x equals 2 out to this curve. So we must look at maybe the entire cylinder would have a radius of 2. If it were an entire cylinder. And this is going to be less than an entire cylinder. It's cutting out this distance. And this distance is actually the y value, the square root of y over 2. That's what I'm taking away from this entire radius of 2. So the radius technically is going to be 2. Take away that long square root of y over 2. Now I'm going to enter this into the calculator. It's going to be math 9 from 0 to 8. Notice I'm leaving out the pi so I can get a more exact answer. I'm leaving out the pi. Going in, I have to add my own parentheses. 2 minus second big square root. Now, a lot of people messed this up. They didn't put the radical over the entire fraction like it is in the problem, and it gave them a slightly different answer. So, and I'm going to lie to the calculator and tell it I'm using x instead of y. And now, remember I added my own parentheses? I want to add the second set and square that, and that's the quantity squared there for my calculator. I know it's with respect to y, but I'm just lying to the calculator so it can generate the answer for me. And here it comes. It's thinking. 5.33. Notice it uses a little bit of a rounding error there. We have to interpret this as 5.33, and the way to get the calculator to generate our fractional answers, again, to lie to the calculator until it adds 5.3333, and then I'm just going to math, enter. I'm going to hit math, and then enter twice, and it's 16 over 3 is my final solution. 16 over 3, but I didn't put that pi there. I have to add that pi at the very end. Okay, for number 10, first I want to get a sketch of it. I know what that square is going to look like. It's going to be just a basic parabola. Concave up going through 0, 0, but this one's a little tricky. And what I'm trying to do is find out where they intersect to get that shaded region. So what I'm going to do is set them equal to one another to find out where they intersect. So I have x squared set equal to 4x minus x squared. Some basic algebra. I'm going to add x squared to both sides. That's going to give me 2x squared equals 4x. And then I'm going to subtract 4x from both sides. So that gives me 2x squared minus 4x equals 0. And I can factor out a 2x times an x minus 2. And I'm going to use the zero product property. So at x equals 0, these two curves are going to intersect. And notice at x equals 2, the two curves are going to intersect. So at 0, 0, they're going to intersect. And at x equals 2, when I throw 2 in there, it's going to be at 2, 4. So I'm just going to do a little cheap graph here at 2, 4. So the x squared graph is going to come like this, and they're going to intersect. And the negative x squared graph is probably going to look something like this, and intersect there. And notice the shaded region is going to be between x squared, negative x squared, and x squared. And notice it says spin about x equals 6. And that's horizontal to the x-axis, so it's going to be with respect to x. We already noticed that they intersect at 0 and at 2, x equals 2. So I'm going to set up my integral. But when I spin it about this, the reflected image is going to be somewhere up here. And notice that's going to give me a washer. There's going to be gaps. So the general formula for the washer formula would be pi from a to b of the outer radius squared minus the inner radius squared with respect to x. So my a to b is 0 to 2. My outer radius is from this curve, or this line, to this curve. And since this is y equals 6, this distance here is less than 6. How much less than 6? It's x squared less than 6, because the distance from here to here is x squared. So that outer radius is going to be 6 minus x squared. Squared. Minus. Now I need to find my inner radius. And my inner radius is from y equals 6 to this curve. Notice, it would be 6 all the way from y equals 6 to the x-axis. But I'm taking away this distance, which is 4x minus x squared. So minus that whole distance, 4x minus x squared. Again, let's rely on the calculator for this key in. I'm going to neglect to put in the pi. Remember that, we're trying to get an exact answer. So math 9, from 0 to 2. I'm going to use a lot of parentheses. 6 minus x squared, close parentheses, squared. A lot of people forget to square that again. A lot of people forget to double square it. Minus, parentheses, 6. Now I'm going to distribute that negative across the blue. Minus 4x plus x squared, close parentheses, square that. Again, a lot of people forget to square that again to the x. Also, remember, I don't have the pi in front of this. 21.33. I'm going to hit math, enter, enter. That gives me 64 pi over 3.